Okay. So let us consider this example. Remember the properties, inequality properties, that if m is smaller or equal to f of x and smaller than capital M for any x between a and b, then we have that integral from a to b of m dx will be smaller than integral from a to b fx dx smaller or equal to integral from a to b of m dx. So where small m and capital M here are constant, right? So integral from a to b of small m here, what do we have? What do we have on the left-hand side of the inequality here? B minus A, because B is the upper bound limit, okay? Very good. From properties of integral, right? And the right-hand side here, the same story. M is a constant, and the width of the rectangle will be b minus a. Therefore, this integral will be okay. So it means that if we are given any function f of x, we know the minimum and maximum. We can estimate the integral of this, right? So let us consider this one. So use these properties to estimate the upper bound and lower bound of the integral from 0 to 1 of e to the negative x dx. Second, evaluate this integral. Okay. So the above integral of properties. Do you have any questions, Remy? Bound, upper bound and lower bound. Yeah. You're welcome. Sorry. Yeah, which it cannot reach over or lower. Then, in order to use this properties, right, we need to find the maximum and minimum of the function in this interval from 0 to 1, right? How can we find a maximum and minimum in this interval? Very good. Thank you, Daniel. So we need to compute the first derivative of this guy, right? And let us call fx is e to the negative x here. Then we have that the first derivative of this guy, what is it? Very good. It would be derivative of e to the negative x. And from chain rule, we know that it would be the derivative of negative x and e to the negative x here. So derivative of negative x give us negative e to the negative x here. Thank you. So the function f of x is e to the something. What can we tell about it? Whether it is positive or negative? It's always positive, right? Very good. Thank you, Remy. And this guy is negative of a positive number. Therefore, we can make a table, right? Make our life easier. We study for any value x between 0 and 1, and we see that f prime of x would be this guy. It is a negative of a positive thing. Therefore, it is always negative, right? Because it is always negative, from the first derivative, it will tell us that the function fx here is always, is it increasing or decreasing? Yes, decreasing. So let us make it this way. Decreasing, right? So what is the maximum and what is the minimum? Yes, max is at 0 and min is at 1, right? So can we find the value of the maximum and minimum? It would be the f at 0, and what is it? Again, please. Be careful. It is e to the negative 0, right? We evaluate the value of this at 0. We replace x by 0. E to the 0 or negative 0 it is. From the power rule, it tells us that, okay, the negative power, we can bring it down to the denominator, okay? And one more thing, any numbers raised to the 0, it would be 1, right? It would be 1 divided by 1, or? Yeah, that is one way. Or you can think of negative 0 is simply 0, and e to the 0 is 0, right? So it's even easier. Okay? Therefore, the maximum of this function on the interval from 0 to 1 would be 1. And what is the minimum value? E to the negative 1, right? E to the negative 1, the same story. This is the negative power, so we can bring this guy to the denominator. It becomes e to the 1, 1 divided by e to the 1, or it is 1 divided by e. And remember, e is 2.7 something, okay? It's simply a constant, right? Now, we know that from this, we know that the function f of x is always smaller than the maximum value and larger than the minimum value here, okay, on that interval. Therefore, from the inequality properties, it tells us that we can take integral from 0 to 1 of 1 over e dx, integral from 0 to 1 of fx dx smaller than integral from 0 to 1 of 1 dx. Okay. Gary, can you help me? What do we have in the left-hand side here? One over e, yes, very good. It is 1 over e multiplied with 1 minus 0, right? Simply give us 1 over e. And the right-hand side here, it would be 1 multiplied 1 minus 0. Very good. And we call this guy the lower bound. And this guy is the upper bound. So we estimate that, okay, this integral cannot be smaller than the lower bound, and it also cannot exceed the upper bound, right? So we estimate the value should be between this. Very good. So in order to answer the second question, we need to compute it. Okay? Compute integral from 0 to 1 e to the negative 1, a negative x dx here. Okay, in order to find this integral, what do we need to do? Very good. Thank you, Daniel. And what is the antiderivative of e to the negative x?
E to the negative x.
Be careful. It is negative of e to the negative x. It's very tricky right here, right? We evaluate when x is equal to 0 to x is equal to 1. So we can double check this guy, right? Check the antiderivative. That negative of e to the negative x derivative, right? Vikram, can you help me? What is the derivative of negative e to the negative x? So first, here the negative sign. We can take it out of the derivative, right? It is a constant. So we get rid of this first, we bring it out. And now derivative of e to the something. If you don't remember this, look back the formula in the notes I gave you. This is e to the u, right? And u in this case is negative x. From the formula, it would be the negative sign, we just rewrite it here. U prime, which is negative x prime, e to the u. It is e to the negative x. Let's do it slowly, right? Then what is the derivative of negative x? Yeah, -1. So it will be negative of -1 times e to the negative x, right? And negative of negative give us a positive. It will be e to the negative x. This is exactly the integrand here. So our antiderivative is good, okay? That is how we can check it, okay? If you do not remember some formulas, go home, review them. So can you all follow it? People on Zoom, do you have any question?
Nope.
Thank you. Okay, it's clear, right? So from here, let us continue. It will be from this guy. Oops. Let me write it. Give some rooms here. It will be negative, the whole thing's here, right? The whole thing's here. We evaluate that when x is equal to 1, it will be negative e to the negative 1 here, right? Subtract the evaluation when x is equal to 0. It is negative of negative e to the negative 0. Okay? Then it will be, what is it here? Yes.
1 over e.
Thank you. And here, negative, negative, and e to the negative 0 is 1 already, right? Therefore, it will be, yes. So, thank you. Was that on Zoom?
Oh, that was Garrett.
Garrett, thank you, Garrett. So is it clear for everybody? That is one way to evaluate this one. And when you do it more time, you will see that, okay, there's another way to evaluate this value from here. From here, you can think of this way. It is also equal to negative of e to the negative 1 subtract e to the negative 0 here. There are two ways to think about it. But if you do this way, remember there's a bracket here. Then it will be negative e of 1 over e minus 1. Right? When you FOIL it, you get the same result as this one. So you should be very careful with the negative sign. So that is what I want to remind you. Okay? So this is our result. Okay, 1 minus 1 over e. We have this result. 1 minus 1 over e. This is the result. And the lower bound and upper bound is here, right? One over e. It makes sense, right? You can double check it. So So do you have any question about this example? Very good. So now let us compute another example. Okay. Evaluate the integral from 3 to 6 of dx over x here. This way they write it a little weird, right? But it's okay. You'll get used to it. Let us write it in the way we normally see. Something multiplied with dx, right? So what is the integrand in this case? Thank you, Morgan. So this is from the quotient rule, right? Fraction. Do you all see it? Very good. Then remember, what is the antiderivative of 1 over x? ln x, yes. Or more exactly, ln of absolute value of x. And we evaluate the value from x is equal to 3 to x is equal to 6, right? From this interval, it means that x is between 3 and 6. Okay. Is it positive or negative when x is? Yeah, positive. So we can ignore the absolute sign right here, right? Ln of absolute value of x. When x is positive, it would be ln of x, right? The same thing. Okay. But we should pay attention on this because you see it later. So now, what is it now? Yes. Very good. Thank you, Carson. So that's it, right? Can we simplify it? Huh? Very good. Thank you, Daniel. Yeah, the difference rule, and it will be ln of 2. Very good. Okay. Do you have any question up to this point? Very well. Now, let us move on to another example. What is wrong with the following calculation? Integral from -1 to 3, 1 over x squared dx, it is negative over negative 1, negative 0.3. So, is it correct? Why?
It's not defined at 0, but the bounds include 0.
Yeah, perfect. Thank you, Daniel. Is a perfect explanation. Because this function, remember, you can always draw a graph of this guy. Suppose this is the graph of 1 over x squared. Then the graph of this guy is like this. And the interval we consider is from negative 1 to 3. It includes a discontinuous point at 0 here, right? So we should be careful because, and furthermore, this integrand, is it positive or negative? Oh wait, this is a wrong graph. I'm sorry about that. It should be like this. My bad. Like this. Okay. Yeah, makes more sense. This integrand is always positive, so we expect that the integral of a positive function would give us a positive number. However, the solution here is negative, so we can see it immediately. So, and in order to do this, because there's a discontinuous point right here, what we could do is to separate this into two integrals, right? From definition, we can compute the limit of these two. And when you write it out explicitly, you see that the limit will goes to infinity. And therefore, it is not defined. The integral here does not exist. Okay? That is one thing we should keep in mind. Because f of x equal to 1 over x squared is not continuous on negative 1 to 3. So be careful. So Now we can play with some other problems. Let me see. So do you have any questions up to this point? Okay, let us practice some more. Integral from 0 to 1 of 10 x to the 4th dx. Let us play with a simple one. Okay. What should we do? We need to find the antiderivative of this guy, right? But before doing this, we can use the properties c multiplied with its function, where c is a constant. We can take it out of the integral. So it makes our life a little bit easier. So let us do it first. Okay. And what is the antiderivative of x to the 4th? Very good. And we evaluate the value from 0 to 1. Right? You can, yeah, it will be 10. You can do it this way. 1 over 5. And what is it next? Right? Subtract 10, multiply with 1 over 5. What is it here? So this guy on the last term, 0 to the 5 will be 0. Multiply with anything, it will be 0. This guy is 1. It is 1/5. Multiplied by 10, it will be 10 divided by 5 or 2, right? That is one way to evaluate this guy. Or now when we do it many times, you can do it this way. This is a constant. we can take it out of this guy. 10 divided by, multiply with 1/5. X to the 5 from 0 to 1, right? Then we simplify this parameter first. What is it? Yes. When x is equal to 0 to 1, then it will be 2 multiplied with 1 to the 5th minus 0 to the 5th here, or simply be 2 multiply 1. It will be 2, right? They are the same result, but many ways to evaluate. So if you face a complicated function here inside, let us make it simpler first, so we can avoid mistake in the future. Okay. Very good. How about this guy? Integral from 0 to 2 of 2x cubed minus 6x plus 3 divided by x squared plus 1 dx here. So what should we do now? Look at the notes I gave you in section 5.2. Integral of a sum or a difference will be the sum or the difference of integral. Therefore, let us make it easier first. Right? It will be integral from 0 to 2 of 2x cubed dx, right? Then subtract integral from 0 to 2 of, what is it next here? Yeah, 6x here. And here's 3 divided by x squared plus 1, right? So now we deal with each of them. But before doing that, we can also do this step. The constant here, we can take it out of the integral, make it simpler, right? So when we do so, it will be 2 integral from 0 to 2 of x cubed dx minus and what is it next here? Very good, and very good. Okay, so now our job is to find the antiderivative of x cubed, x, and this guy. If we can do so, then we can evaluate the value of this guy, right? So the first term, what is the antiderivative of x cubed? Yes, x to the 4th over 4 here, right? Evaluate from 0 to 2. The second guy, 6 and Yes, 1/2 x squared or x squared divided by 2, the same thing. From 0 to 2. And here, the last one. Do you remember? Yeah, you can look at the table. Inverse of 10 x here from 0 to 2. Okay? So go home and look at the derivative table. You will see this guy. Okay, now, before evaluating the value here, let us simplify the constant first to reduce to avoid mistake. Okay? So 2 divided by 4, 6 and 2 here, what does it become? Yes, 1/2 x to the 4th from 0 to 2 minus, very good, and 3 here, right? So then just evaluate this guy. It will be the constant, we keep it outside here. Inside the parentheses. Now we can write it. What is it now? Can you help me, Gary? Very good, thank you. So the way I do it, this way, it helps us, we do not have to deal with writing 1/2 many times, right? So remember, open the parentheses here. The same story, it will be negative 3 and, was it here? Yes. 3 and 10 inverse of 2 minus 10 inverse of 0 here, right? Okay. Then 1/2 of 2 to the 4th, it will be 2 to the 3rd, right? 3 here, minus 3 times 4 plus 3, 10 inverse of 2, or yeah, just write it this way when we and 10 inverse of 0 gives us 0. So finally, this guy, it would be 8 minus 12, it would be negative 4, right? And does it. Okay? Is it clear? So go home, review the antiderivative, do it many times to memorize as much as you can. And I'll see you tomorrow. You don't have to come here tomorrow, but we will do it via Zoom. Okay? Yes, at the same time. You have a good weekend. See you, everybody.